So we're starting section 6.4, and this is dealing with trig identities. So take a moment, and you might want to write these up on a chalkboard or just someplace where everybody will be able to see them. Our fundamental trig identities, our big one is sine squared of theta plus cosine squared of theta equals 1. Then if you divide all three pieces of that by sine squared of theta, you get 1 plus cotangent squared of theta equals secant squared of theta. Or if you were to divide each of those by cosine squared, you would get tangent squared of theta plus 1 equals cosecant squared of theta. All right. A few other fundamental trig identities. Cosecant of theta is the same thing as 1 over sine of theta. Cotangent of theta is the same thing as 1 over tangent of theta. Secant of theta is 1 over cosine of theta. Tangent can be written as sine over cosine. Cotangent can be written as cosine over sine. Sine of a negative, the negative pulls out to the front. Same with cosecant, tangent, cotangent. With cosine, the negative drops away completely, and with secant, that goes as well. All right, so we're going to be using these fundamental trig identities today and tomorrow, and for a little while. All right, so let's simplify using trig identities. Let's say you're given cotangent of theta divided by cosecant of theta, and you need to simplify it. Well, cotangent of theta can be rewritten as cosine of theta over sine of theta, and then cosecant of theta can be rewritten as 1 over sine of theta. So now we're dealing with a fraction divided by a fraction, and to take care of that, we'll leave the top one alone, so cosine of theta over sine of theta, and then we'll multiply by the reciprocal of the denominator, so this becomes sine of theta over 1. The signs cancel out, leaving us with cosine of theta. Now, it's also possible to simplify by factoring. So down here, this can be rewritten on the top. You have a perfect square minus a perfect square, so you have your two sets of parentheses. Sine of theta minus 1, sine of theta plus 1. In the denominator, what can you take out of both terms? Well, you can take out tangent of theta, leaving you with sine of theta minus 1, which is really nice because those cancel out. So up top, we have sine of theta plus 1 over tangent of theta. Okay. Now, when you're adding two fractions, you have to have a common denominator. Just because we're dealing with trig function, that doesn't change that fact. So a common denominator for sine and cosine is to just smush them together. So sine of theta times cosine of theta. On the top, we'll need to multiply 1 plus sine of theta by cosine of theta. Got that big fat plus sign, so we write a big fat plus sign on our problem. Our second denominator, cotangent of theta minus cosine of theta, we need to multiply that by sine of theta. All right, so let's focus on the numerator for a moment. Cosine of theta times 1 is cosine of theta, plus cosine of theta times sine of theta, just sine of theta, cosine of theta. Big fat plus sign, big fat plus sign. Cotangent of theta times sine of theta, whoops, pencil malfunction. All right. Sine of theta, cotangent of theta, minus, multiplying those, that'd be sine of theta, cosine of theta. All right, so I'm actually going to make it like that so that this looks really obvious. We have a positive sine of theta, cosine of theta, and a negative sine of theta, cosine of theta, so those two cancel each other out. So on the numerator, we have cosine of theta plus sine of theta. Now, instead of cotangent of theta, I'm going to write that as cosine over sine, which is nice to do because now the signs cancel out, and we have cosine of theta plus cosine of theta. And anytime you're adding things together, 1 cosine of theta plus 1 cosine of theta gives you 2 cosine of theta. So that's our numerator. our denominator is still sine of theta, cosine of theta. And if you look at it this way, cosine gone, now we have 2 over sine of theta, which is the same thing as saying 2 times 1 over sine of theta. And we know that 1 over sine of theta is the same thing as cosecant of theta. So we took those two big old fractions, added them together, worked it all the way down to 2 cosecant of theta. Okay, let's take a look at one more. All right, now we have 3 sine squared of theta plus 4 sine of theta plus 1 over sine squared of theta plus 2 sine of theta plus 1. You've got squared, and then to the first power makes it a quadratic, which means you should be thinking about factoring. Now, for some people, it's easier if you remember that sine of theta is your y value. So technically speaking, you could rewrite this as 3y squared plus 4y plus 1 over y squared plus 2y plus 1. If the signs are kind of throwing you off a little bit, you can use y instead of sine of theta. The top factors into 3y plus 1, y plus 1, and the denominator factors into y plus 1 times y plus 1, which is great. The y plus 1's cancel out, leaving us with 3y plus 1 over y plus 1. Just remember that you need to replace the y with sine of theta, so our final answer here is going to be 3 sine of theta plus 1 over sine of theta plus 1. There we go. All right, so for tonight, you're going to be simplifying by using fundamental trig identities or by factoring. And your assignment is on page 497, numbers 10 through 18 even. Good luck.